Educational GMAT. Your partner in your GMAT journey.
Not difficult at all if you understand it clearly. Yes, guys, is the question clear? How do we approach this? Okay, out of 20 students, how many students do we have to choose? 3 students. So if there was no constraint, then this would have been easy. In how many ways can we choose 3 students out of 20 students? So then the answer obviously would have been C23. Yeah. Correct? What's the constraint here, however? The teacher will not choose a group of 3 students whose names are in 3 consecutive positions on the list. So out of these, obviously, what will we subtract? What will we subtract? We'll subtract total number of groups of 3 students whose names are in 3 consecutive positions on the list. Do you agree? From this total number, we will subtract the total number of groups of 3 students whose names are in 3 consecutive positions. And because this is what the teacher does not want to be included. Are you guys with me? Okay, now it's really simple, guys. Now let's say A is first student, B is second student, C is third student, D, E, F, and so on. Right? Till 20th student. Correct? Now, what does it mean when we say 3 consecutive positions? Can you tell me? In simple words. ABC. Very nice. ABC is one group that cannot be included. BCD. BCD is another group that cannot be included. CDE is another group that cannot be included, and so on till when? Till last. What will be the last group? See, 1, 2, 3, right? 1, 2, 3 is one group that cannot be included. 2, 3, 4 is another group that cannot be included. Are you guys getting me? 1, 2, very nice. 1, 2, 3 is one group that cannot be included. 2, 3, 4 is another. 3, 4, 5 is another, and so on. Considering that there are 20 students, what's the last group that cannot be included? 18, 19, and 20. In other words, how many such groups cannot be included? 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on till 18, 19, 20. So total of 18 groups. What's not here again? Oh, just minus 1. Yes. So out of the total number of 3 student groups that was possible, 18, these 18 groups are not allowed as per the constraint. So you just subtract 18 from this. Those difficult groups, these are 18 Is it clear now? How quickly computing? I'm not sure how. Yeah. How did he? Because it's 3-member group, Nikhil, right? 1, 2, 3, 2, 3, 4. So this has to be 3. So it has to, obviously, the last group has to start with 18. See, for example, if it starts with 19, right? Then give me 19, 20, and 1. These are not consecutive. right? So the last group that is consecutive would be 18, 19, 20. And then, yes, absolutely. Starting with 1, starting with 2, starting with 3, and finally starting with 18. So total 18 groups. Oh, Siddharth has calculated the final answer also, which I have not. But is the approach clear, guys? Is the approach clear?
Well, it was quite difficult to change
Okay.
at 18. Okay.
So that's the whole point. Total number of 3 student groups whose names are not in 3 consecutive positions on the list would be total number of 3 student groups that can be found from 20 students and minus total number of 3 student groups whose names are 3 consecutive positions on the list. So this is 20C3 and this would be 18. We just discussed it 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on till 18, 19, 20. So 20C3 minus 18. Yes, that's the answer that Siddhant was getting. Yes. Yes, should we proceed? Something is not clear.
No, that's clear. I just wondering how to approach like that. Coming to 18 was tough. Like how we decided how we should decide 18 is the one which teacher won.
How did I decide that 18 is the one? Well, because of this statement. If the teacher will not choose a group of 3 students whose names are in 3 consecutive positions. So if you look at a class register, right, it's from A, B, C, D. Alphabetical, it clearly says anyway, right? D, E, F, and so on till 20th, right? So 19th, 20th, and the first would not be considered consecutive. So it's not an endless cycle, right? So that's where I said these 3 will not be counted, these 3 will not be counted, and so on. And the final one that will not be counted is 18, 19, 20. So, and so starting with 1, starting with 2, starting with 3, and finally starting with 18. So 1 to 18, that's 18.
In my mind, I was planning to write all the 1, 2, 3, 4, 4, 3, 4, 5, 4, 5.
Yeah, that would not be feasible writing everyone. That's not, and now I'm going to keep understand that's not required also.